Welcome to Sri Chaitanya. Welcome to JEE MAX, JEE Mains Advanced Extreme Series, Season 2 of JEE MAX. Through this season, we are completely concentrating on a particular chapter, very important for both the mains and advanced and board examinations also. So far, successfully, we have completed 45 lessons. This is lesson number 46. And from lesson number 40 onwards, we are completely concentrating the last part of the complex numbers, which is de Moivre's theorem. Now, this is a de Moivre's theorem of complex numbers, de Moivre's theorem. And my friends, again, I am requesting, please don't forget to check the description. There I am providing very good important links and important assignments along this video, and if possible, the links of the previous videos also. Anyhow, now in a de Moivre's theorem of complex numbers, in lesson number 46, today we are covering the problems of integrated textbook, icon integrated textbook. Because if you mastered all the problems given in integrated textbook, each and every problem in exercises, and moreover the solved example problems from the integrated textbook, you can do anything, any objective questions, even for JEE Mains and Advanced. That's why it gives the solid foundation. So to strengthen your foundation point of view, only here I am concentrating all the problems, solving all the problems from the integrated textbook. Today, through this lesson, we are concentrating problem number 8, and of that 1 to 9 problems. Now, coming to 8th problem. 1 omega square are cube roots of unity, then prove the following. Now, this is the first question. 1 by 2 plus omega, 1 by 1 plus 2 omega equal to 1 by 1 plus omega. You know that if omega square 1 are cube roots of unity, then 1 plus omega square equal to 0, and omega cube is equal to 1. With the help of these two results only, we are deriving all the given important problems of that number 1, first problem. Now you take better LHS. So 1 by 2 plus omega plus 1 by 1 plus 2 omega. Of course, instead of LHS is equal to RHS, you can prove the problem. You can take LHS minus RHS, consider. So minus 1 by 1 plus omega. Now I want to show this as 0. So take LCM, that is a 2 plus omega into 1 plus 2 omega into 1 plus omega. So here 1 plus 2 omega into 1 plus omega plus 2 plus omega into 1 plus omega minus 2 plus omega into 1 plus 2 omega. Now multiply. This is 1 plus omega plus 2 omega plus 2 omega square plus 2 plus 2 omega plus omega square minus 2 omega minus omega minus 2 omega square by something denominator. 2 plus omega, 1 plus 2 omega, 1 plus omega. Now simplify this. This 2 omega square gets cancelled. This 2 omega gets cancelled. And this is omega and this is omega gets cancelled. And here 2 gets cancelled. And finally, what I got, 1 plus, of course, here once again, here 1 plus 2 omega into 1 plus omega, 2 plus omega into 1 plus omega, yes, 2 plus omega into 1 plus 2 omega. Perfect, right? So 1 plus omega plus 2 omega plus 2 omega square, next to 2 plus 2 omega plus omega square minus 2 minus, this is 4 omega, sorry, 4 omega. So again, this 4 omega, you know, so 2 omega plus 2 omega, this gets cancelled. So ultimately, I got 1 plus omega square in the numerator by 2 plus omega into 1 plus 2 omega into 1 plus omega, but that is 0 by 2 plus omega into 1 plus omega, which is equal to 0. That's all. So LHS is equal to RHS, it comes. This is about to proof. Now coming to second problem. Here the second question is, now I am erasing all the steps of problem number 1. Now coming to problem number 2. Here two problems are there. One is 1 minus omega plus omega square whole power 6 plus 1 minus omega square plus omega whole power 6. Okay. What is 1 plus omega square? That is minus omega. So minus 2 omega whole power 6 plus, and similarly 1 plus omega is minus omega square. So minus 2 omega square whole power 6. So this is 2 power 6 is actually 64. So 64 omega power 6 plus 64 omega power 12. But omega power 6 is 1, omega power 12 is 1, because omega cube is equal to 1. So 64 plus 64, 128. These are all models several times they asked in the board examinations as well as in the mains examination also. Even they are useful for MSET examination. So next, coming to 1 minus omega plus omega square. This part I am now solving, this part. 1 plus omega, 1 minus omega plus omega square whole power 7 plus 1 plus omega minus omega square whole power 7. This I can write it as minus 2 omega whole power 7 plus minus 2 omega square whole power 7. This is 2 power 7, that is 5. I think this is minus 2 power 7. That is 2 power 6 is 64, that is 128, minus 128 omega power 7, and again this is minus 128 omega power 40. I can take minus 128 as common, therefore minus 128 omega power 7 as common, then I may get it as 1 plus omega. 1 plus omega is again this is minus 128 omega power 7 into minus omega square. So ultimately I can get 128 omega power 9, that is 1. So I got answer as 128. This is about what second problem. Now coming to third problem, my suggestion would be, please remember the third problem, because sometimes in some problems we may occasionally or accidental or intentionally we can apply the essence of third problem as a support to solve for other application problems. That's why you please practice the third problem and by heart the result also. Now LHS. This is A plus B into A omega plus B omega square into A omega square plus B omega. What I'm doing is A plus B, you take like this. Now you just multiply this. This is A omega cube plus AB omega square plus AB omega power 4 plus B square omega cube. So this is A plus B into, this is A omega cube is A. Next, this again A square omega square, A square, and this is you take AB omega square as common, you can get 1 plus omega square, and this is B square. So finally A plus B into A square minus AB plus B square I can get. So this is nothing but what, A cube plus B cube. That's all, is equal to RHS, is equal to RHS. So I got this result. So please be careful in complex numbers. What is A cube plus B cube? If anybody is asking you what is A cube plus B cube, then immediately you can factorize A cube plus B cube like A plus B into A omega plus B omega square into A omega square plus B omega. Applications you will enjoy in the next any other lesson. Okay, now coming to 8th problem, 4th, 5th, 6th, 7th questions. Okay. Similarly, just like in third problem, now LHS of a fourth problem I am taking. So LHS is x plus y plus z into x plus y omega plus z omega square into x plus y omega square plus z omega. So you keep this term like this, x plus y plus z. Now you multiply this. This is x square plus xy omega square. Next, plus xz omega plus xy omega plus y square omega cube plus yz omega square plus xz omega square plus yz omega power 4 plus z square omega cube. So this is x plus y plus z into, of course, this is x square and omega cube is 1, so y square plus z square. See here, this is xy omega square, and is there any other term? Xy omega is there. If I have taken common from this term as well as this term, there I can get minus xy, similarly minus yz minus zx, and after simplification this is very familiar, that is x cube plus y cube plus z cube minus 3xyz. This is straight question. Now coming to the fifth problem, x square plus 4x plus 7 equal to 0, that is 0, where x is equal to minus omega square, omega minus omega square minus 2. That means indirectly what they are asking you to prove, that we need to substitute, you need to prove that omega minus omega square minus 2 whole square plus 4 into like that. But I am solving the fifth problem in another way. So x is equal to what? Omega minus omega square minus 2 is given for me. So what is my x plus 2? This is omega minus omega square. Now squaring on both sides. So x square plus 4x plus 4 equal to omega square plus omega power 4 minus 2 omega cube. This is omega square and omega power 4 is omega, and minus 2 omega square, again it is nothing but omega minus omega square. Again my omega minus omega square is x plus 2, I can write. So this is x square, so x square, see once again, omega minus omega square, right, I'm right, whole square, omega square plus omega power 4 minus 2 omega cube, 2 omega cube, sorry, this is 2 omega cube. This is 2 omega cube. So it becomes 1. So these two are wrong. So omega plus omega square is minus 1, and this is minus 2, this is minus 3. So directly I can get x square plus 4x plus 7 equal to 0. I got it. Similarly, you please by heart problem number 6 as well as 7, because they are also very, very useful, just like the previous questions. And coming to fourth problem, a plus b whole cube plus a omega plus b omega square whole cube plus a omega square plus b omega whole cube. A omega square plus b omega whole cube. So this is a plus b whole cube. You keep it this side, and this is a cube plus 3a square b, 3a square into b, that is b omega square, plus 3ab square, 3ab square, that is b square omega power 4, plus similarly a cube, that is a cube omega power 6, plus b 3a square b, 3a square b plus 3ab square, 3a omega square b omega plus b cube omega cube. You simplify this. This is, again I can also write it as a plus b whole cube, and of course this is a cube, and of course again it is what, plus 3a square b omega square into omega square omega power 4, that is omega, plus 3a b square, this is omega power 5, that is omega square. Similarly, plus a cube plus b, 3a square b plus 3ab square plus b cube. Yeah, plus b cube, I have forgotten this term here, plus b cube, that is b cube omega whole power 6. Again plus b cube you can get, and plus similarly a cube plus this is what? 3a square b omega power 5, that is omega square, plus 3a b square, 3a b square, because this is a cube plus b, 3a square b plus 3a b square. So this is omega plus b cube. You simplify this, you can get a cube plus b cube finally, plus a cube plus b cube finally, and a cube plus b cube. These three terms you can get. After that, this you can get a 3 into a cube plus b cube. That's all. Now coming to seventh problem. See, just like what is called just like sixth problem, seventh problem is like this. I think you can also solve a sixth problem in another way, because a cube plus b cube plus c cube is equal to 3abc. That is there. You can also apply, you can also solve the sixth problem in this way. Suppose if you add a plus b into a omega plus b omega square plus a omega square plus b omega, that is 0. We know that if a plus b plus c equal to 0, then implies what? A cube plus b cube plus c cube is equal to 3abc. You can also apply for solving this problem. That is another strategy. Now here, coming to seventh problem. In the seventh problem, actually this is a plus 2b whole square, a plus 2b whole square plus a omega square plus 2b omega whole square plus a omega plus 2b omega square plus 2b omega square whole square. This I can write it as a square plus 4b square plus 4ab plus a square, that is a square omega power 4 plus b square 4b square omega square plus 2ab, that is 4ab omega cube plus a square omega square plus b square 4b square omega power 4 plus 2ab, that is 4ab omega cube. This is after simplification. A square plus 4b square plus 4ab, and this is plus a square omega plus this is 4b square omega square, and this is plus 4ab and plus a square omega square plus 4b square omega plus 4ab. So if I have taken a square as common, then a square into 1 plus omega square I can get, plus b square into 1 plus omega square I can get. Similarly, plus remaining terms I can add. This is 4ab, 4ab, that is equal to plus 12ab I can get. So finally, this has simplified with the answer as what? 12ab. That is sixth problem. Now coming to eighth and ninth problems. If omega comma omega square and 1 comma omega square are cube roots of unity. These two problems already they have asked several times in board examinations also. Now eighth problem. 1 minus omega plus omega square whole cube. This I can write it as minus 2 omega whole cube. This is minus 8 omega cube. So this is minus 8. That's all. Now ninth problem. This is about eighth problem. Now coming about to ninth problem. This is 1 minus omega plus omega cube omega square whole power 5 plus 1 plus omega minus omega square whole power 5. This is 1 plus omega square is minus omega, so minus 2 omega whole power 5 plus this is minus 2 omega square whole power 5. So this is minus 32. If I have taken common, this is omega power 5 plus omega power 10. So this is minus 32 into 1 plus omega plus omega squared I can get. So this is minus 32 into minus 1. So this is what? 32. You can get answer. So the answer is 32. So these are all the simple models, though they are simple, but they are very, very important for board examinations and of course for MSET especially, sometimes mains also. Okay. And the essence of these and applications of these problems we may expect sometimes in mains advanced examination also. Okay. Hope my friends, if you like this video, please share and subscribe my channel. Please don't forget to check the description and please don't forget to press the bell icon. Thank you. We will meet with the next lesson soon. Thank you.